All right, so we started functions on Friday.
So you didn't answer.
We didn't really talk about what a function was. We just talked about like how to determine if something is a function. So now I'll tell you a little bit about how functions are used. And they are used again, just like all math. They are used. You may not wind up using them. Some of you will. You might use it and not know you're using it. But a function, it's kind of like, I'm going to use an expression that you'll hear for sure in your lifetimes. I don't know when you'll finally hear it, but sometimes we say that something is a function of another thing. It's related to this math that we're about to learn. So for example, I might say that your grade on a test is a function of how many hours you study. It just means they're related. It means that somehow the number of hours affects directly what grade you get. Now, functions, like it doesn't have to always be a positive. Like you may think, oh, the more I study, the higher and higher my grade's gonna get. But that's not necessarily true. Why isn't that true? Who knows why that's not true? Give me an example of why that's not necessarily true forever. It's true a lot of the time, most of the time, but there are reasons why that's not true at some point. What's the highest grade you can get on a test? So you can't, so if you study and your grade goes up and up and up, at some point your grade can't go up anymore, right? So you keep studying, you can't get higher than a 100. So again, it doesn't go up forever, so it's not a straight line, it kind of goes up and up and up, and then it just kind of goes flat, because you can't get higher than 100. Or it might even start going down, like you might study so much you don't get any sleep, and then the next day you don't do as well as you would have done if you would have gone to bed and gotten good sleep. So anyway, functions can be all kind of different relationships between numbers. And that's what this means here. When you talk about data, you're going to see this word relation in this particular topic a lot. It's not a big deal. It's just saying that there's some kind of an association between the numbers. Like 2 is related to 3, like they go together. You could actually literally think of them as a relationship, like people have a relationship. 2 and 3 are in a relationship together. 3 and 4 are in a relationship together. 4 and 5, relationship together. So a relation just means like there's an association, like the numbers match up, like whatever, I don't know what words you would think of on your own, but within the relationships, there are different kinds of relationships. Some of them might be functions, some of them might not be functions. So you're going to see all of these terms. You're going to see the term domain and range a lot, which we talked about on Friday. We'll go over that again, especially since a lot of people are absent. All right, so, but for right now, let's just figure out, is this a function or not? A lot of you got the yes part correct. It is a function. Some of you had a pretty good explanation of why. Some of you weren't as sure how to explain it. Here's the easy version. If you don't have this down, or if you don't truly understand it, you need to write this down. It'll be probably something easy on either the exit ticket or the quiz based on what I'm about to say. If in your set of data, it could be a table form, because we said this. Oh. We said this data could be shown in many different forms. We could show it in ordered pairs, and an ordered pair is just an X and a Y. So that's one way to show data. So again, if you think of test scores and the number of hours, you might say, well, I studied for 4 hours and I got a 97. That would be one ordered pair. I studied for 0 hours and I got a 62. I studied for 1 hour and I got a 71. I studied for 3 hours and I got a 90. So again, that's just data. That's just data. You have an input, which is the number of hours you studied for, which is your X. X is always the input. and then your output is kind of like the result. What did you get based on studying 4 hours or based on studying 0 hours? Well, so we could put this data into a different format, and we could put it in a table instead of having it in a whole bunch of X and Y coordinates. So we could say 2 and then 3, 3 and then 4, 4, 5, 5, 6, 6, 7. Same exact data, no difference whatsoever. Same, if they would have been our test scores, we could put the test scores in that. Same test scores, same number of hours studied. We're just showing it in a different way. And we talked about what was the third way, or not, yeah, I guess you could say it's the third way. What was the one she did in the video that we probably hadn't seen before? Who was here has it written down? Nobody in the last one.
What you talking about? What?
She showed us a new form that we could put data in.
Oh, that little.
Yeah, the thingy thing.
That's
what last class called it, the thingy thing. You drew it, the thing you drew. You drew it and Zakira drew it. What's it called though?
The domain and the range.
Yeah, but what was the thing called that she was using? The thing you drew. The thing you drew to turn those points. What's that? No, the thing you drew with the circle.
I don't know what that is.
Oh, nobody wrote it down? I should start giving credit for some of this stuff, like extra credit for just having stuff.
The output, input.
No, it's a whole. It's not any. It's not any individual piece. It's the whole thing is called something.
Circle. Independent. Oval.
There is. Well, it's not really a
Y'all
circle.
dumb.
Oval.
I got half of it correct. Yeah, I
So
said circle,
X and
that is a
Y.
circle.
Well, that's not. It's not called a circle.
It's a stretch. It's like a really thing.
Not called a circle.
Yeah.
So what was my first point? 2, 3.
Yeah.
So we said the data could also be written like this. We could write the data in a relationship like this. And we could set, now the problem with this is we don't know what's paired up with what. Like in a table, they're right next to each other. And the ordered pairs, in the ordered pairs, they're right next to each other. In a diagram like this, it's called a mapping diagram, by the way. You will see that on a test, so you may want to understand what it means. I don't know that they'll make you create one, but just in case, you're going to want to know what they're talking about when they say it. Mapping diagram. I could have sworn you said circle.
You did.
Circle, mapping diagram, they're very similar in sound. But
Circle mapping and circle.
so they can have you create this, so you need to understand what it is. I'm not gonna probably have you, I doubt I'll have you create one. You will have to understand how to use one. So they will not always be side by side in a mapping diagram. So you can't just say, oh, well, I know, no, in this one they are, but that's because I gave you an easy problem. Now, the way that we pair up the X and the Y here is we have to draw lines to say which X goes with which Y. So here we would say, well, that 3 goes with that 2. This particular mapping diagram is also called something specific. It's called a one-to-one. So you should have that written down. If you didn't copy that down, you can copy it. It's one-to-one because there's only one arrow coming out every number, and there's only one arrow going into every number. So it's pretty self-explanatory. But you have to draw the, well, you don't have to draw the mapping diagram, but it's easier to see from a mapping diagram. And normally that's the only time they're gonna, I shouldn't say that either. They might ask you that about a graph or about a set of ordered pairs or a table. They could ask you that a lot of different things. I shouldn't say they'll only ask you that when it's a mapping. Not just yet. I got to get through, because we're kind of doing the bell work in a lesson all together. So this is a one-to-one. Again, one arrow coming off of each of these. One arrow going into each of these. And we're going to use this and a concept a few times today. The first word is related to the X's. The second word is related to the Y's. All right, so anyway. Do I want to go? No, I'm not going to go over that. So we said that there is one easy way to tell, sometimes, not all the time, easy way to tell from a set of coordinates or a set of ordered pairs, and then a set of ordered pairs that are in a table. If this happens, it is automatically a function. Automatically. If there is no X value, just the X, we don't even care about the Y's, we don't care about the outputs, the range. If there is no X repeated, so again, no X value repeated, it's automatically a function. So if you don't have that in your notes, or if you don't just remember it and understand it from the video, you need to write that down. If there is no repeated X value, it has to be a function. There's no way it can't be a function. Yep. I'll give people time to finish writing what they remember what I said. So, again, if there is no repeated X value, so that means no X value is repeated. Like we don't have an X value repeated here. 2, 3, 4, 5, 6. None of them are the same. Now you can only do this with a table and with a set of ordered pairs. Because in a diagram, we don't repeat them anyway. We never write an X value twice in a diagram. So we'll go over that in a little while. So this is only for tables and, tables and ordered pairs. You could use it for graph, but there's a better way to do it on a graph. So this is only for tables and ordered pairs. So tables, charts, you could call it tables or charts. Tables, ordered pairs is the only time this works. And it doesn't work. This is only part of the way you tell if it's a function. It's definitely a function. But it could still be a function even if this doesn't happen. So again, if no X value is repeated, then it is definitely a function. Automatically a function, definitely a function. It is a function, whatever you want to write. I'll give you a chance to finish writing that. So in this case, we don't have a repeated X value, so that was really your main explanation on why it's a function, and it is a function, we said. You could just say, well, no X value is repeated, so it's got to be a function. And you will, without a doubt, see that when it comes to the function lesson, you will see functions where there's not a repeated X value. It should be an easy one to pick out. Whether it be my test, whether it be a state test, a district test, there is no doubt that will be one of the options on one of the questions. All right. So hopefully everybody has that, I think. Hopefully everybody's awake. Oh, nope, not all awake. Oh, somebody popped up. Oh, they both popped up. But one didn't. All right, so here's the new lesson. So that was old material from the video. This is the new lesson. So we talked about these three. I'm going to zoom out, by the way. We talked about these three methods of seeing data. So we talked about these three methods. Let me get rid of, I'm going to get rid of just the mapping diagram. So there's three ways we've talked about that you can view data. You can put it in ordered pairs. You can put it in a table. You can put it in a mapping diagram, but there's a fourth one. We haven't talked, well, I mean, we've done it before, we just haven't talked about it relative to what we're talking about right now, functions. I could graph it. I could put ordered pairs on a graph, right? We do this all the time. We are still working sometimes on putting them in the right spots, but we do it all the time. I could graph these ordered pairs, and I could put them, what is it, 2, 3, 3, 4, 4, 5, 5, 6, 6, 7. There we go. Graph them, put them on the graph. So here's the next easiest part of this lesson. Actually, this is easier than the last one. This, along with the thing that I'll review next, are the two easiest parts of this lesson. Everybody, kind of like finding the y-intercept on a graph of a line, you don't have to know anything about math. You have to look and see what I'm about to show you, and then you can know the answer. You will know the answer. There's this thing called, here, let me do this real quick. I do have to zoom in a little bit. Come on. There we go. What?
I can put your charger thing on there. Yeah, it's good.
No, not my computer. You got a, you have a box?
Nope.
No, not on my computer. Is that nice? God, smartboard sucks. Hate smartboards. All right, let's zoom in one more. Yeah, somebody's probably got a box. All right, here we go. So, I now have 4 ways I can display data. I have this, it's all the same data, by the way. I didn't change any of the numbers. I'm just showing these ordered pairs as a table. I'm showing them as a mapping diagram, and then I put them on a graph. So here's the easiest way you can ever tell if something is a function. You need to take your graph. So here, write this down. Is it a function? It's a little game we're playing. Is it a function? No. Write that down. I mean, we already know this particular set of data is a function, but I'm going to show you how you would do it with a graph. So, is it a function? And this is when looking at a graph. Use the vertical line. All right, so I've had about enough. I've tried to talk over it, hoping you would eventually end the conversation, but it's nonstop. So let's knock it off. Good Lord. All right, so when you are looking at a graph, use what's called the vertical line test. If you can't see that, it's vertical. It's vertical. There is nothing easier we're going to do in this lesson than what I'm about to show. This is actually just as easy as using the mapping diagram to see if it's a function. They're about the same as far as difficulty level. So I'll show you this one and I'll remind you how to do the vertical line. I'm sorry, the mapping diagram. So if you have a graph and they're asking you a question, and the question is this set of data on the graph, is it a function? You don't even have to understand what in the world a function, I almost said that. You don't even have to understand what a function is. All you need to remember is to tell whether or not it's a function. You all better be awake for this, because like I said, it's the easiest thing you're going to do. You need to watch this, because it's the easiest thing I'm going to do for this lesson. You need to take some kind of a straight edge. And by straight edge, it could be a ruler, it could be your pencil, Could be a calculator edge, could be an edge of a paper, edge of a notebook. It needs to be straight. All you need. And then you need to do your best job to make it vertical. So vertical means straight up and down. So I'm using this green line. What? See, I need to. Ah! Try that again. So you need a vertical line. I'm using this green line right here. Can't really get out of the way too much. If I take this green right, oh, actually here, I can't. If I move that green, it doesn't matter if you go from left to right or right to left, that doesn't even matter. You need to move that vertical line left to right or right to left. If you never hit two of the coordinates, basically 2 points of whatever data they've given, you never hit two of them at the same time, it's function. Like I said, you don't have to understand what a function is. You just take a straight line and you go left to right, a vertical straight line. And again, I'm just hitting 1 point right here, right? I just hit that one. Over here, I just hit that one. I'm not hitting any of them in between, which that's fine. Doesn't matter if you don't hit any of them at all. There is never a point, didn't work. There's never a point where I hit two of those data points, the red points, at the same time. So it's a function. The only way it's not a function is if you hit two of them at the same time. So here's what I want you to do then. We said this, and I don't care which version you do it, which one you use. You can use the ordered pairs, the table, whatever. I want you to give me an ordered pair, so an X and Y, so like these. Give me an ordered pair that would make this not a function. It would no longer be a function. So we'll see. Kylie, you can type that into the chat box. So, Kylie, I want you to give me an ordered pair that would make this not a function. This set of data. You understand the concept. All right, I'm gonna walk around and see what you got. Oh, I better do it then. Which one is it? Oh, it's here. That'll work. Not sure. Okay. They just want to go over it. Not sure. All right. Did you give me a point? All right, so we'll talk about that one. I gotta remember that one from a 0. Not yet, not until I do the rest of this one. You're in line, but you can be after Devin. 2, 3. That one we'll talk about. So what do you write? -2, -3, 4, 9. That one would be good. Oh, so this steps. That'll work.
Oh. Don't look at that.
Where's your answer? You don't have to give me one ordered pair. Like not write a whole lesson.
Not used to it as well.
But those be fine.
Wait.
All of those work. Yes, every single one of those. You only had to give me one, but all of those would make it not a. Well, that would still be a function. First of all. Oh, wait, are you saying these go along with this? If that's the case, then that would be correct. So, but you would add them into here. You would just create another line. You don't need to well, actually, these you would have to because they're not already in there. 3, 4, 5 are already in there. So you wouldn't write them again. You just draw a line like right in 1 and 2, and then draw a line. But yes, those are working. So let's see what we got over here. Good, good. Answer?
That is cash.
So this one's new word. This one's already in there. So that one is not changed. We already had it. 3, 4 was already in there. 2, 3 was already in there. This wouldn't change anything. You're adding a new pair. So the only way to do it is to have the same X, different Y. This 2, 3, you made it 2, 5. That's the only one that worked. But that one would. All right, so most of us did a pretty good job on that. Those of you that did not, though, you need to pay attention because this is guaranteed test and maybe exit ticket question. If I need to make this not a function, if again, you may have this problem from any kind of these formats. They might give you this kind of a format, meaning a table, and say, give me a point that makes that not a function. You got to create it in the table. They may give you ordered pairs and say, give me an ordered pair that makes it not a function. They may give you a graph and say, give me a point that makes it not a function. So you need to know how to read all of these. I think the easiest one is the graph. Because what did we say has to be true for it to be a function, or not true, depending on the way you look at it, if we have the graph? What's the test we're doing? We need to make sure that we don't hit any 2 points at the same time if we want to keep it a function. So the opposite of that is if we don't want it to be a function, we just need to make sure it does hit 2 points. So we need to put a point somewhere above or below one of the points that are already on it. And that's how you would do it with a graph. Because if I put a point above or below here, let's say down here, well, when I go left or right, I'm going to hit those 2 points at the same time. Right? Oh, I did it again. Hate it when it does that. Yikes. Hate. Is that it? And then now I gotta go down. There. So now if I scroll left, I'll hit both. So anytime you hit 2 points, it's not a function. So now I hit 2 points. So here's the questions I've given in the past. I've given a graph and I've said, is this a function? And then I've given a graph and I've said, make this relationship into something that is not a function. All you'd have to do is put a point anywhere above or below one of the points that are already on there. Because then you're going to hit them twice when you do the vertical line test. So there's like an infinite number of answers. So a lot of you, very rarely will the answers be duplicated. So because you could put 2, 1, 2, 2, 2, 4, 2, 5, 2, 6. I mean, there's an infinite number. 3, 1, 3, 2, 3, negative 4, 3, negative 6. I mean, it could be all kinds of points. Now, if I just gave you ordered pairs, I think that's a little trickier, but basically all you need to do is repeat the x value and have a different y value. And then that makes something not a function. So you could pick any of the x values, repeat it, but make sure you don't pick the same y value that's already there. So if I pick 2, I could pick any number except for 3. If I picked 3, I could pick any y value except for 4. What if I have this? Get rid of all of that writing. Is this a function if I add this in? Is it still a function? I want you to write down on your papers if this is still a function.
No.
I want you to write it down. Write it down. Let's see what we got. I'll start. All right. All right. In. All right. What you got? Is it a function? Yes or no? You don't need to write anything else. Just function, yes or no. All right. All right. I'm not even asking you to explain it.
Oh.
All right. I will start bathroom now, but I think.
I'm not gonna shave them.
So the pass is in the tray. Put your phone in there, please. No. So it's kind of split down the middle of the class. Probably a few more no's. Yes. Yes. Ooh, and then we caught up with a bunch of yeses over here. I have a feeling they might have been colluding a little bit. So here's the way you tell. This is the same test you do every time. You just do it again with the new information. If, as long as I put in an x value and I never get a different y value, it's a function. I can put it in twice. It doesn't matter if I put it in twice. So I put in 2, I get 3. Put in 3, I get 4. 4, I get 5. So it's function so far. Now I finally repeated an x. I put in 5. Well, I put in 5 once. So imagine my function machine. I put in 5 once, and I got now. If I put in 5 again, I better get that same number. Every time I put in 5, I better get that same number. And I did. I got 6. Got the same number. As long as you get the same number out when you put that input in, it's still a function. So that is a function. You may be saying, well, wait a minute, though. Now we'll have 2 points on the graph, so we touch 2 points. Well, no, you're not going to put another point on the graph. We wouldn't plot this point again. It's already on there. So we still just have 1 point there. That's the way you have to think of it. Now, technically, you do have 2 different data points. But when it comes to the graph, if a point is on top of itself, like it's the same point, you're not hitting 2 different points. It's got to be 2 different points. When it comes to a diagram, like if we added this point in, we're not drawing, remember? Oh, so here's the next easiest thing you need to know how to do. We said when you have a diagram, here, let's go to this real quick. So this is what some of you missed last week. If you have a mapping diagram, there is some of you will think it's easier than the vertical line test. I think the vertical line test is pretty easy, but this is pretty easy too. What is the way we said is the super easy, quick cheat sheet way to know if a mapping diagram is a function or not? What do we say? Well, those of you that were here Friday, a lot of you weren't. What was it? Somebody tell me you took notes. What was the super easy way we said Friday when you have a mapping diagram? There's an easy, just as easy as the vertical line test. Some of you don't think it's easier. So whoever's now, hold on just a second. Do you know the answer to this? You weren't here, so hold on just a second. I'll speed it up. If you get a map, you need to write this down in your notes, especially if you're not totally getting this stuff, because this has nothing to do with really understanding any of this. And I hate that, but it works. Every once in a while, I'll give you one of those. If you have a mapping diagram, this is how you tell if it's a function or not. Whether you understand this doesn't even matter. You look at the inputs. That's all that matters, the inputs. You don't need to look at these at all. Completely ignore them. Completely ignore them. Don't worry about them. They actually make it more confusing. Just look at the inputs. If you only have one arrow coming off of every input, it's a function. Simple as that. Like I said, you don't have to understand a single thing about functions other than the fact that that's what it's representing when you have a mapping diagram. But I have a single arrow coming off D4, a single arrow from D5, a single arrow from E2. if I were talking about the bell work, I have a single arrow coming off 2, a single arrow, a single, single, single. All of those single arrows means that's a function. The minute I repeat one, somebody give me the one of them that's makes it not a function. Give me one. Somebody, give me one that makes this not a function.
Oh.
2, 2, what do you have? 2, 2, it would, but I don't have those numbers in there, so I'm going to do a different one. Somebody give me another one.
3.
3, no, it's got to be 2 numbers. 3 what? 3, 4 is already on there, so that would still make it a function because it's 3, 4. We put in 3, we get 4. That's fine. Should get 4.
42.
Yeah, but I want numbers that are already in there. Use the numbers already in there. 3, 6 works. So let's say we add the point 3, 6 into our set of data. Well, according to my mapping concept, like if there's 2 arrows coming out, it's no longer a function, and this shouldn't be a function, because when we put in 3 before, we got 4, but now we're putting in 3 and we're getting 6, so that's not a function. And if I did the mapping diagram, I would have to draw that line, because we don't ever repeat numbers here. Never repeat a number in a mapping diagram. You only draw arrows to show that it's being used multiple times. So now, if you'll notice, I just drew 2 arrows coming out of the 3, which means it's not a function. We said anytime you see 2 arrows or more than 2 coming from one input, that is not a function. So going back to this other one, ignore the outputs, just look at the inputs. And if there's more than 1 arrow coming off of any input, it is not a function. So this one we said was not a function. Not okay means not a function. This one we said was okay, meaning it is a function, because they're all single arrows. And then this one had 2 arrows coming off of it. So that made it not a function. So between that and the, who was next then? You next? Shayla did that. Did you ask? So I don't remember who was next. Shayla was the next one I remember.
I was after Shayla.
And I know you, actually, yeah, you were also in line too. So I think you and then Shayla and then Mariah.
After them, can I go?
And then you can be after them. So if you want to go, you can go now. I wanted to make sure I got through this because this is a super easy concept, so get a question right. All right, so look at, did I already have you get one of these?
No.
All right, so all of you come up and get one of each of these. One of each, yeah, you should have 3. Oh, shoot, I got to go over one more thing on this. Go ahead and get those, though. Yeah. Be careful because it comes out super fast. Yeah. It gets dried and then kind of, that makes it shoot out super fast. All right, so I need you to draw 3 types of these mapping diagrams. So you're going to draw one just like this. Draw one. You can change the numbers as long as you have 2 arrows or 1 arrow, 1 arrow, 1 arrow. but then going into only one thing on the right. Yes, this is notes, definitely. You can copy the exact same ones down if you want, but you could change these to different numbers and these to like other numbers.
We're doing both okay and not okay, or just okay?
What's that?
We're doing both not okay and not okay?
Yeah, you're doing, but you don't have to copy all of this. Like literally just do the input, output, input, output. I did X, Y, but it's the same thing. So copy those. Draw this. And then these two, you don't have to do all this okay, not okay, blah, blah, blah. Just the X, and then this grouping, the Y, that grouping, X in this grouping, Y, that grouping. You can even change these to numbers if you want, as long as they're different numbers, 3 different numbers. The important thing is the arrows. That's the important thing. Make sure you have the arrows matching up the way they are up there. You getting all straight there, Shane?
Yeah, I was getting paper for these three.
Oh. I'll give you a minute to do that.
Which one are we on first? Or we haven't started running yet?
If you want to get started on the worksheets, you can. You do need to watch this because this is something you'll need for the worksheets. But you should be able to do the first problem from the worksheet without any more lesson. There she is. Good.
Sorry, my mom's doing better.
Good.
He's so good.
She's finally able to eat.
Good. That's fun. Well, I really need Renata to be.
These are for your first page.
Oh, I was gonna say I had a few of them, but not many. All right, so who's still writing? All right, hurry. I'm adding something to it today. Hold on, I want you here for this too, please. You can hang on, you can sit in that chair briefly.
I got stand.
Or that. We'll tell you what, I'll get started and I'll go over it again. So we talked earlier about how this is a one-to-one. There is one arrow going into one output. One arrow going into one output. All right, hope she's got it. This is called a one-to-many. You still have only one arrow coming off of each of these, but it's going into like mini pretzels, I guess. Like there's multiple pretzels here. Technically, this is representing pretzels twice. So there's many on this side, repeated things on that side. One to many. And then the last one is the opposite. Now you have multiple things repeated here. D4 is actually repeated twice. D4 goes with pretzels, but it also goes with chips. So this is many to one. Again, just remember that the first word goes with the inputs, second word goes with the outputs, and the many part just represents something that's duplicated. You got multiple arrows there. So here we have multiple arrows, so this is the many part. Here we have multiple arrows, so the many part is on the output. And here we only have one coming off, here we only have one going in. So that is part of one of your worksheets. So you'll need to understand what that means in order to do one of the worksheets. So I think we're good on that. So you should be able to do, oh wait, one more thing. Actually, go ahead on the worksheet, the one that says, do you know how? Ignore the domain and the range part of the first one, or number 5. I just want you to say, is that a function or not? You can explain why if you want, if you really want to make sure you understand how, but is it a function or not? So, and these, you're turning in all three of these, so we're kind of doing them right now. So you'll have a lot of this done by the time you turn it in. It's Do You Know How, number 5 is the one you're working on. Yeah, there were 3 worksheets. All right, so you should be done, shouldn't take long. The key is, how do we check to see if it's a function when we're doing a graph, when we have a physical X and Y axis and graph? How do we check? What's that called?
Vertical line.
Vertical line test. You need to take some kind of a straight line. You need to use your pencil. I mean, it probably is obvious if you just look at it. You don't even have to take something to move it left and right. If you see 2 dots that are directly above and below each other, or more than 2, that's not a function. Because if you moved a vertical line left to right, you would eventually hit both of those dots. So you don't even have to do the whole vertical line test. You can just see, are there any dots that are directly above and below each other? If there are, then it's not a function. Because what it's saying on that one, it's saying we have these coordinates, -4, -2, right? And then we have -2, oh, let me show you one thing. They give you horrible graphs sometimes on some of this stuff. It is really confusing to look at this and try to figure out where some of the numbers are. So here's how you do that. Find the x-axis. It's the one with the arrows on it. You see how there's like a little arrow there? Find the y-axis. It's the one with the arrow on it. They're at the bottom in the left too. Make sure you know where those are. And then you can actually like maybe even draw them in a little darker. I'm going to draw them in red. Where they cross is 0, 0. So that will help you understand if this is 0, 1, 2, 3, 4. If this is 0, 1, 2, 3, 4. If this is 0, -1, -2, -3, -4. If this is 0, -1, -2, -3, -4. So if you ever get a graph that's really visually hard to understand, make sure you kind of redraw in the X and the Y, and that'll help you know where the numbers are. So now that I've done that, I can write down the rest of the numbers. So this is -2, 1, -2, 2. And then I have -1, 0. That one's a little trickier. I should have made you guys do this part. And then 3, 1, and 3, -2. So I just rewrote all of these points in a different format. I could have written them in a table. I could have written them in a mapping diagram, which I might have you do that part. All 3. One of each. So if we do the vertical line test, is this a function? Raise your hand if you think it's a function. Raise your hand if you think it's not a function. Yeah, if you do the vertical line test, not only do we hit 2 dots right here, but we hit 2 dots again right here. That's why I say that this is an easiest way. If they give you a graph, nobody should miss. Or if I give you a graph, nobody should miss whether or not this is a function. Although there are some trickier versions of it, which I'll go over in a second. They're not on any of your work. Wait, did I go over the other versions, like something like that? Did I do that yet?
No.
Okay. I do have to do that. So all this is saying then, if I had the dots at one point, or at I put an input of -2 in and I got 1 out. Right? Into my function machine, I got a 1 out of my function machine. Every time I put in -2 after that, I better get 1 out. I better get the same output every time. Well, I don't. I put in -2 again right here. And then I got a different output. That can't happen if you want it to be a function. So as soon as that happens, it is no longer a function. Graphically, that's pretty easy to see. But that's all this graph is saying is when we put in -2, one time we got +1, but then when we put it in again, one time we got +2. That's why the vertical line test works. It's just matching up the inputs and the outputs, and you have too many outputs for that one particular x value.
What, I'm gonna ask a stupid question. What does it mean that it has a function? What does that mean?
That something is a function?
Yeah.
We went over that at the beginning of class, but I'll explain it for you, Miss Oates. So you've heard this saying because you've obviously got a lot more experience of hearing English phrases. Say, well, this is a function of that. Like you've heard that just in the English language. Oh, well, like your grade on a test is a function of how much you study. It just comes from this. Like it means something is kind of related to something else. I hate to say it causes it because it's not necessarily true, but there's certainly a correlation. So your grade is a function of how much you study. The temperature is a function of the time of day. Like as it gets later in the day, the temperature goes up. But then as it gets later, at some point, it actually goes down. So that's kind of where the term comes from, is because this is definitely a science thing. Like they would use this in science a lot, and in higher math, I guess. Like I'm sure, like rocket scientist type people probably use this kind of stuff a lot, and a much higher level.
They use it when they're plotting programs.
Well, that's the one we're going to get to in a second. All right, so go ahead and, so now let's talk about domain and range. So we need to know what domain and range are and how to create the domain and the range. What is the domain? If you were here Friday, you better be able to answer that. What's the domain?
Wait, is this a function or not a function? Is this not a function?
What do you think?
I don't think it is. I don't think it is.
Absolutely not, because there's 2 points where we'd hit the same, there's 2 points on the graph where we would hit 2 points at the same time, there and over there.
Oh, wow, you know what works.
So, those of you that were here Friday,
It's your
what is it's the inputs, but which values do we use? X's, the domain is your X's. So here's the next thing you need to know how to do these worksheets. If you're going to create the domain from a list of data, a set of ordered pairs, a graph, whatever it is, you need to pull out all of the X values. You do not duplicate any of them. So you need to write that down. So this is actually for domain and range. So domain is just the X values, range is the Y values. So step 1, write them from smallest to largest. Again, for the domain, you would be writing the X values. For the range, you would be writing the Y values. So write them from smallest number to largest number. And then the only other rule, don't duplicate any of them. So I'm going to do this one for you. Now you can do this from the graph. You don't have to pull these out. If that makes it easier for you, then I'd say go ahead and pull them out. I would just say, so from smallest to largest, I need to write my X value. So my smallest X value, I look through all my X's. All right, well, my smallest value is -4. Now my next smallest value, I just so happens, I guess I wrote these in order already. My next value is -2. Now my next value is -2 again, but I don't duplicate them. I do not write -2 twice. Remember when we did the mapping diagram, we said we don't duplicate in the mapping diagram. The mapping diagram is basically already your range and your domain and your range. They've already pulled the X's and the Y's out and they didn't duplicate them. So whenever you have a mapping diagram, whatever is on the left is your domain, whatever's on the right is your range. So I don't write -2 again, so I go straight to -1, then I go to 3, and again, I don't write 3 again, so that's my domain. -4, -2, -1, and then 3. So now let's do the range. Actually, you guys do the range. So follow these rules. Write them from, so the range is the y values. So you're going to look at all the y values, write them from smallest to largest, but then don't duplicate any of them. So you guys do that one. You're doing the range now. I just did the domain for you. You're doing the range.
Just write the numbers. -4, -2. Oh, you're right. What's smallest to largest?
Oh. All right, let's see what you got. All right, you guys need to be doing this. I don't want to have to walk around every single day with my clipboard, but if I got to go back to that, I will. I mean, you're going to have the exit ticket on in 2 days, so you don't know how to do it. For those of you that complain about your grades and constantly send me messages and ask me how do I get my grade up, well, you take notes and you do the problems when I ask you to do the problems, because then you'll do well in the exit tickets. If you do not do well in the exit tickets, you will not get your grade up. Simple as that. The exit tickets are what get your grades up. All the classwork in the world is not going to get your grade up to where you want it, because the class grades are already pretty high. So the only way you're going to get your grade up is to do well on an exit ticket and a quiz, which you still have one more quiz this quarter. At least, actually, you have a midterm this quarter too. So you have a quiz, an exit ticket, several exit tickets, a quiz, and then a midterm. All right, so again, I'm giving you an exit ticket on it in 2 days, so I'm not going to walk around and give grades for it. That's going to be on you. Here's the answer. -2 is my smallest y value. And I look down, what's my next smallest? Well, I don't have any other negatives, so my next smallest is 0. So -2 and then 0. Then after 0, my next smallest is 1, then 2. I don't repeat any of them. I put them in smallest to largest, so that is my range right there. That's the range. So hopefully you guys got that. So for number 6, answer number 6 on your own. You should be able to do that. We just went over how to pull out the domain and range. You already know how to determine if it's function. You need to redraw it. Was somebody out? Or is my pass just over there?
So just write the 4, the 2, the -4, the -2, the -1, and the 3. That's your domain.
Oh, yeah, that's it.
And the range are the exits, the y.
You have phone?
You understand?
Then phone jail.
It's not hard. It's just something you have to remember.
So I'll give you a couple more minutes on that. I think 7 is really kind of the same thing.
Or the y.
If you want to go ahead and do 7, you can go ahead and do 7. ECJ records. Oh, actually on number 7, you have to graph. So you can use graph paper. If you don't have some graph paper from graph paper that I've given you before, there's some up here. But on number, or you can just draw your graph, that's fine. If you want to just draw out a quick, actually just draw a quick graph. I'll show you how to draw it. So for number 7, go ahead and do that one. So for number 7, you don't need any negative numbers. So when you create your graph, just create it like that. So this would be 0, 0 here, because we don't need any negative numbers. So then on this axis, it looks like the x value, oh shoot, yeah. Let's move that over a little bit. The x values go all the way up to 10. So you just want to, I mean, you don't even have to write every single one of them in there for this. You can just write it by 5s. Just say, well, that's my x-axis, that's my 5, about 5 and 10. If you want to write in every single one and say 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, you can do that too. And then over here, you only need to go up to the y value. The highest y value is 2.5, so you don't have to go up very high on that at all. So we'll just say that's 5. And then just put the points in the best spot you can. The key is you're doing the vertical line test, but again, you don't have to do the vertical line test. You know how to figure this out without using the vertical line test. So that's how you do 7. We already did this for bell work. This would be the vertical line test again. I'm not going to go over that again. You'll see it another day again. So for number 13, identify so I just told you about this. When you have you have a question? What's that? No, you're good. Have a seat. So, identify the domain and range of each relation. Is the relation a function? So the domain and the range, when you have a mapping diagram, they've already given you the domain and the range. It's already there. They've separated out all of the x's. They didn't duplicate any of them, and they put them in order from smallest to largest. That is your domain right there. That is your range right there. So a mapping diagram is super easy. They've already done the domain and the range for you. So I wouldn't say it's a trick question, but it's a pretty easy question. You just need to remember this is domain, x's are domain, y is range. So your domain would just be all of these values, smallest to largest. None of them duplicated. Here, just 3 values. This is this an example of 1-to-1, 1-to-many, or many-to-1? Doesn't ask you that, but I'm curious. Yeah, it's 1-to-many. I got 1 arrow, and I got many arrows crammed in over there into one of them. So easy. Good. So for that one, you should be able to do domain, range. I kind of just told you the answer to domain and range. And then you just have to say, is it a function and why?
Mr. Gill?
Yes.
She has an emergency. Can I take her to the restroom?
I don't believe she does. She just went like
That's
5
what I
minutes ago.
thought.
Who was drinking that water?
Yeah, I have a feeling she's going out to meet somebody or something.
She didn't have her.
No?
Her phone's right there. Oh, wait, no.
I can't believe that you literally came back 5 minutes ago. All right, go. You burned me on this though. Again, I trust you up until I get burned, and then I'll never trust you again.
I'll go with it.
All right, there you go. Perfect. Cool. You should be able to do 14. Again, you're just giving me the domain, the range, and is it a function? It's a diagram, so it's pretty simple to do all 3 of those. It's a mapping diagram, is what I mean by diagram. So yeah, I think you should be good to go. Oh, so here are the ones you actually do. You don't have to do every single problem. There. So on these worksheets, you're doing page 1, 5, 6, and 7. So page 1 is the do you know how page. So that's page 1 is the do you know how page. So you just do 5, 6, 7. I think we already did them. Um, so page 98 is the one with all the stuff on it. There you do 13, 14, 18, 19, 20, 21, and then you skip from 21 to 27. You don't have to do 22, 23, 24, 25, 26. And then on the 3-1 page, so it says 3-1 up top, you just do 1 through 7. You don't have to do number 8. 7 is tough. I'll just tell you right now, do your best on 7. If you can get 7, then you're getting this. Like, you got it. If you don't understand 7,
No, there's no 19 on here. No 19.
Yes, it is. Yes, there. Where? It's on the side. See? 18, 19, 22.
Oh, I'm stupid.
yeah, that's not, those two next to each other are two different
Oh.
problems. That's funny that you both caught them.
What problem you do?
So I'll walk around. You got a good 15 minutes to work. You should be able to do most of these on your own, but I'll help. So now we didn't really talk on 18 through 21 about how to tell if it's one-to-one or one-to-many from a graph. So you should definitely be able to say whether or not it's a function. As far as figuring out the one-to-one and the one-to-many, all that stuff, that's a little trickier, but try to figure it out. Hold on just a second. They're coming back, so yeah. Put your phone in there and the phone JLCs. So again, so if you didn't just hear me, 18, 19, 20, 21, the poor little graph. It says to say whether or not those are, in addition to whether or not they're a function, it says to tell whether it's a one-to-one, one-to-many, or many-to-one. That is a little tricky, but remember, you're looking for, it's not just a set of points. It'll be easier. You got to try to envision the mapping diagram, I guess. Would you have more than one arrow coming off of an input? Well, if you do, then it's a many-to-one. Or would you have more than one arrow going into an output? Well, if you do, then it would be a one-to-many. So try to envision a diagram when you do those graphs. Or you can even pick a few numbers and create a diagram if you really wanted to. I mean, you should definitely be able to tell me whether or not it's functional. Oh, shoot. I forgot to, no, I'm recording, but I forgot to tell you one more thing. Or not tell you, but show you. God dang it. So here, let me show you real quick. So in this particular problem, I don't want to mess that one up. Hold on. Let me help you out with the graphs real quick. Oh, it's not even on that stupid. There, this one. So on some of the problems, you're going to have some really weird graphs. Like I gave you graphs that just had some points on it. They're going to get into some goofy looking graphs. Now, some of them aren't bad. Like some of them you just may have a straight line. So if I do so everybody needs to pay attention to me real quick. I'm not repeating this because every individual's going to be like, oh my God, what is that? I do the vertical line test every single time when I have a graph. I just go left to right. God, why is it doing that? I'm gonna break this one day. You're gonna come in, and there's gonna be a hole through and that thing's gonna be on the ground, shattered. I'm like, I don't know how it got like that. I don't know what happened. I don't know what happened. Oh shoot, I probably shouldn't have been recording that. I mean, I would never do that. So let's try that again. So if I do the vertical line test, I just drag this left to right, right? Are you kidding me? What in the world? That didn't, thought maybe if I slammed it down, but nope. So if I go left to right, I just hit 1 point every time on a straight line, right? Pretty simple. All right, well, let's try a different kind. Maybe if I use this more often. What about if I had a little different line like that? Does that really change anything? No. Not really. If I go left to right, here, I'll do it sitting down. That'll fix everything. If I go left to right now, so I drag the line left to right, I still hit 1 point every time. So certain shapes are pretty easy. Like that's not going to be hard for you to figure out. This shape, however, a little trickier. If they give you this shape, it's called a parabola. It's more of an algebra 2 thing, but actually you'll get into it in algebra 1B, I guess. So if I drag the line left to right, you're not. It looks like it might start to turn and you might, like toward the ends, possibly be hitting it twice. You're not. This parabola is always moving just a little bit to the right. It looks like it starts to turn straight up, but it's never vertical. It never goes straight up. It's always moving a little bit out as it goes up. So that is a function. I'll just tell you right now. That is always a function when you see a parabola like that. Parabola is just like that U-shaped shape is a parabola. Now this, however, and again, it's not hard to tell it, but that, obviously, if I go left to right on that, I'm going to hit 2 points on that a lot. That is not a function. Clearly not a function. I'm going to hit 2 points on that line all over the place. So that one would not be a function. They're going to give you some weird stuff like this, too. And this isn't on your... They're going to give you some weird stuff like just lines. And you're going to be like, what in the world kind of graph is that? Just do the same thing. Just do the vertical line test. Just go left to right. If you ever hit 2 points, it is not a function. Well, on this one, if I go left to right, I don't ever hit 2 points, right? Here I only hit this one little red dash. Here I hit this one. Here I hit this one, but I never hit 2 points. Now, if all of a sudden I did this, and I put some points on the graph, like there's one, there's one, there's one. Now when I go left to right, clearly I'm going to hit at least these two together. Right, so I hit that red point and that line, which means I'm hitting two at the same time. So now it's not a function. So don't worry about how weird the graph looks. Just do the vertical line bit. If you cross over 2 points or more than 2 points at the same time, it is not a function. Doesn't matter how weird the graph looks, you're just still doing that same vertical line test. And that'll get you through the 4 graphs. Try to figure out if it's 1 to many or many to 1. That's a little tougher on that. You don't have to do 15 through 17. 27 is a good one. I like 27 a lot. I could see me putting that on a quiz or something like it. So spend some time looking at that. I mean, you should be able to do all the other ones. So. I'll get a stapler in a second. I think it's Aaron.
Yeah.
1 through 7. Everything but 8.
7. It's 1.75, no, it's almost to the 2.
So, I guess I'll leave the recording. It's only 7 minutes. You have to say.
Almost, we only get a stay for 2 months.
Done?
Almost equal to 2. The figure is $1.75 is close to $2. So it's almost to the 2. Okay, it's becoming a straight line. So it is a function. And you do the 4 and the 1? Yeah, okay, no, check it out. And nothing repeats. So is it a function? Nothing repeated, so is it a function?
Yes.
Yes, so yes. Put number 7 under you.
It says
Stay
1 and 1
together.
is not.
Put number 7.
So you're supposed to tell me if it's a function.
Good.
Actually, supposed to tell me.
Well, work on this one.
Go back and do
Well, while
those.
I'm here, I can help.
It's coming to say.
On the output? There's 2, there's
Can we put this up?
and there's a 3 and a 1.
You have just the rest of the class to work on it, so,
Goes with.
again, I'm not gonna get on you about today, taking the last 5 minutes, that's up to you. You're the ones that have an exit ticket to the next class.
Is that one a function or not a function?
So.
Oh, make sure you put your names on these for when you do turn them in. Don't forget to do that.
What?
It doesn't have to be a function, it's already not a function.
So if it goes to it's not
No,
a.
but if it's, that one goes to purpose and that one goes to purpose, that's okay.
Yeah.
Oh, but one.
So these are gonna be due, I'm not even gonna make them due Friday. Oh, should make them
Can I
Friday.
get a staple?
Turn them in, if you turn them in by Friday, then I'll probably give an extra point on them. If you, otherwise, they'll be due probably next Friday, so like 9 days. or whatever. Now, they need to be completed though, don't just turn them in and you're not done.
So what is the domain name?
So you need to tell me,
Domain
are these functions, like that was the first thing.
name is these, and I
To
said,
determine whether each
There are
relation is a
four
function.
for you.
So are they functions or
I
not?
write R and write T, the Y. Underneath.
There, I need to explain on that one. Alright, I think you're kind of explaining what you're doing now, just tell me specifically why.
I fixed the lock and
Alright, so those of you online, these are, oh, shoot. If you're online, Kylie, you're the only one that's online. You're supposed to download these from Focus. So that was your question earlier, that's, I don't know what the I'm not sure was. I see you're typing. I'm going to go ahead and show you where they are in focus. So this is the, oh, hold on. This is the assignment name. It's CW and then linear functions packet. These are the worksheets that you need to download. It's the ones that I showed on the screen and then the ones that I was just talking about in class. But you should be able to do all of those based on the material today. Again, you can go back and watch the replay if you need to. If you have trouble downloading it, let me know, but I think you've been able to download stuff. I don't think you got any problems. So you can go ahead and leave. That's all we're doing today. Do you have any questions? Are you good? All right. Then you have a good rest of the day.
Where'd he go? I'm 90.
Meeting.